the basic idea is that we let part of the integral, that's the tricky bit really, deciding which bit to let be. Let part of the integral be u to make the integral easier, and then integrate in terms of u. And get it to look like a standard integral. The idea is to get our integral to look like a standard integral. As with all these methods, SI for standard integral. So what we're doing with partial fractions and polynomial, which for the last few weeks was all to play around with it algebraically to get it to look like a standard integral, which is generally the 1 over u integral, which gives us a log. Now we're going to look at some other examples where we use this algebraic substitution, which works in some cases. If this doesn't work, we look at others. We try and use some sort of trigonometric substitution. We'll be looking at integration by trigonometric substitution, and so on. There's different ways. The tan theta over 2 substitution is another one that we probably won't look at, but there are lots of different substitutions we can make. They're all there to try and make our integral look like a standard integral. So let's start by looking at this example, which is in the textbook, work problem 3. So we have to hand, or in our minds, the standard integrals, this table of standard integrals that will then help us. And the standard integral that's useful here is the integral of 1 over x is log of x plus c. So that's the standard integral that we're interested in here, because it looks a little bit like 1 over something, but it's not over x, it's over 5x minus 3. So what we can do with this integral is say the integral of 4 over 5x minus 3 dx with respect to x equals, as we've done before, we can take the 4, which is just a constant outside the integral, so this equals 4 times the integral of 1 over 5x minus 3 dx. So that's the first thing we can do. We can take the 4 outside, the constant, which is always possible, if there's a number there. Now, we ask ourselves the question, how am I going to get this to look like that standard integral? What am I going to let u equal? Right, if I let u equal 5x minus 3, it suddenly looks like it becomes 1 over u. Okay, so we let u equal 5x minus 3. If we let u equal 5x minus 3, that means we can write the integral equals 4 times the integral of 1 over u, but still with respect to dx. So to be able to now do this integral finally and use this standard integral, we've got to change what we're integrating with respect to du rather than dx. And do you remember how we do that, what we do? We've got that u equals 5x minus 3, so what do you think we do with that? Differentiate it. And that gives us du. If I differentiate u with respect to x, I've got du and dx there now. So if I differentiate du by dx, what does that give me? It's 5. Now we rearrange this little, we treat this like an equation. Rearrange it for dx, because I want to substitute that in instead of dx in here. So I rearrange this little equation to read dx equals something. So I multiply both sides by dx, du equals 5 times dx. Divide both sides by 5. Du over 5 equals dx. So instead of dx in the integral, I write du over 5. So the integral becomes 4 times the integral of 1 over u times du over 5, or with respect to du over 5, effectively. Now that 5 is a constant, so that 2 can come outside the integral. 4 over 5 integral 1 over u du. And now we've got the standard integral that we're after. So if we now look back to here, there's my standard integral. Look, that was the whole point of this process, because now this looks like a standard integral. Integral of 1 over x with respect to x equals the log of x plus c. So integral of 1 over u with respect to u equals log u plus c. So this becomes 4 over 5 times the log of u plus c. And final step is just to put back in what u is, because we let u equal 5x minus 3. So it's the log of 5x minus 3 plus c.